Hello everyone, I'm Prikshit here from the channel Talks with Pri, and today we have Mr. Dr. Krishna Thakur, who is an epidemiologist working in the University of Prince Edward Island from more than a decade there, and we will have some questions for him, and he will answer us about the outbreaking viruses which are going to be coming in the future, and also he will be telling us about his practices which he have done in his career. So let's get this thing started. Thank you, sir, for coming on my podcast first of all. And आपसे जानना चाहते हैं कि आप प्रोफेसर हैं यूनिवर्सिटी में, जो यूपीआई यूनिवर्सिटी है, वहाँ पे आप प्रोफेसर हैं. तो कैसे जर्नी आपकी शुरू हुई सर, और आप किस चीज़ में आपकी स्पेशलाइजेशन है, वो सब अगर आप हमें बता सकें.
Thank you for inviting me to talk with you. And I started as an international student. I came here in 2011 for my PhD.
Okay.
And I studied veterinary epidemiology, which is one aspect of veterinary medicine. I studied for almost 3.5 years, got my degree, then had another 3.5 years as a researcher after my PhD. And then after I started a faculty position, became assistant professor.
Okay.
Yeah.
So right now, are you assistant professor?
Yes, I'm an assistant professor.
Tell us a little bit about the epidemiology. What is generally what it is?
Yeah, so epidemiology is basically you study disease in population. Like individual clinicians who treat patients, they only care about their individual patient who come to their clinic.
Okay.
But epidemiologists, they care about bigger group, like not about one individual, but like the entire population or a group of individuals. So it's a branch of preventive medicine. So we want to know like how a disease can be prevented, then
Okay.
it can be treated.
Okay.
And epidemiologists try to understand like why some group of people are diseased, some others are not diseased. Some have higher risk of having like heart attack or stroke or like cancer, while some others don't have. So what are the factors that can explain those differences?
Can you tell us a little bit about what are those factors?
Yeah, there are many, right? Like if you look for say like let's say stroke or like cardiovascular diseases, it's your eating habits, like what food you eat, your lifestyle, are you exercising, how much you are sleeping, your stress level, your genetics, your race, your gender. Many of those factors play a role, like either you smoke or drink, all those factors. So we try to understand like how these factors increase your risk or decrease your risk of having a particular disease.
So you must know a lot about those things, like whoever, what are the things?
Yeah, so and then like you can't study every disease, every condition, right? So people then start focusing on one or two diseases of their interest, and then you try to understand more and more about just one disease or one condition throughout your life. Like it's such a vast area.
So what are you studying? What is your?
So since I'm at the veterinary college, I'm mostly interested in diseases that affects animals.
Okay.
And in that also now I'm entirely focused on salmon. Like salmon is
Fish.
Yeah. So I studied their diseases and how it spreads, like it gets from one individual to another individual, how it impacts their health or behavior or their growth. What are the things that farmers can do to prevent those diseases and all those sorts of things.
Okay. So let's say now you are searching for the salmons, which is a fish, right?
Mm-hmm.
What? So people eat a lot of fish.
Yeah.
So do the disease from the fishes are easily be gone to the people who are eating it, or?
Yeah, there are diseases like that can transmit from the food that you are eating to the persons who are eating those food, like especially from animal sources, and those are called zoonotic diseases.
Mm-hmm.
But particularly in salmon, they are not not that many, and these food that go through like many steps like quality control and all that. So before going into the market, like they make sure like these are good quality fish that are good for consumption, so there's no risk for people. But still, when they are produced in ocean, like the fish itself has risk of getting getting contaminated with many bacteria or virus or other parasites.
Okay, so you are saying even the fish is contaminated by some disease, by going through the food processing, the disease will gonna be remediated.
Yeah, and those diseases don't affect human beings. Yeah, those are mostly fish diseases. So, and before harvest, they make sure like the fish are clean and they don't have any disease.
Okay, what made you choose this particular stream? If you want to tell us, like.
Yeah, so my basic training is in veterinary medicine. I was trained in Nepal as a veterinary doctor.
Okay.
And then when I came here, like, and then epidemiology has always fascinated me, like how disease spreads in population, how you can do it at a larger scale rather than treating one individual dog or one individual cat. You want to have science that can help, like
you want to look at the bigger
picture. Yeah. And that's how I started. And then since I am in PI, like salmon or lobster, it's a huge industry here, like, and that's how I transitioned into fish and all, rather than looking at other animals.
Let's go a little bit in depth for this.
Yeah.
So what is your study about that particular fish, which you have found fascinating, which you have found like this is very interesting, that I find, or that we have find in your university?
Yeah, it's really interesting. Like, not just one disease or one condition. They are like, when they are in ocean, they encounter so many different bacteria, virus, parasites that affect their life, and every single one of those are very interesting. Like how they come into contact with fish, like what happens once those bacteria or virus are inside their body. So, like once you are into that deep search, like everything that you find like that is really interesting, and then you get more and more invested into that. Another thing is like with climate change, like these diseases are becoming like very very common. Like even those diseases that were not seen earlier, they are emerging. They are becoming more.
So you are saying that the human population is growing and it has impact. Yeah, of course, it has an impact on the aquatic life as well, because.
Yeah, not directly, but whatever we are doing, like that's somehow causing problem into all our environment. Like either we are on the land or we are in the water. Either we are polluting the water, or like the greenhouse gas emissions that's increasing the water temperature. And these fish that were used to live at 8 or 10 degrees, like the water temperature is now 12, 14, 15 degrees. So it's not ideal for them. And then they are stressed. They are exposed to these diseases.
Also, how come you said they are stressed, and is there any evidence you find for that particular thing? That, I mean, what is the evidence of that the population is growing? As you said, the temperature of the water is rising.
Yeah.
Right. So what is the evidence that you found that the fishes are not growing, or I mean they are?
No, they are growing, but they are getting more diseases than before, like they used to get before. So they are getting like a higher number of fish are dying while they are being farmed. So the farmers are losing a lot of money. Yeah, and they are getting disease, so they are not producing the like same amount of fish that they were producing from the same amount of investment.
Okay, so as you said, you have researched in salmons. You have any other type of fish that you have?
Yeah, so I also work in India and Nepal a little bit. I have partners there who are, so I like in Canada, it's mostly cold water, like marine fish like salmon. But in India, mostly people like fresh water and warm water fish. So rohu, tilapia, those kind of thing. And yeah, we are studying their diseases as well.
Okay. And just fascinated about this aquatic life. Uh, if you have any insights about the fishes such as sharks or the big fishes like whales or Maclodian.
No, I haven't like thought about those. Like
Okay.
I don't have time to go beyond what I'm doing.
Okay.
So yeah.
Okay. So as you said, you came in PEI in 2011,
Yes. Yeah.
and after that you studied 3 years of
Yeah, for my PhD.
Okay.
And then another 3 years. Like that was not a study, but that was still a training to become a better researcher.
Mhm. So what about One Health goal in this industry?
Yeah, so it's One Health, as you pointed, like if you are eating the fish, should you be concerned like if you get disease from that?
Mhm.
So One Health, like as I said, like clinicians, they are focused on their individual patients,
Okay.
right? And population health people like me, we are focused on a larger group of individuals, not just one, but many, or like hundreds and thousands. And One Health, it extrapolates that concept, and now it looks not just at human or animal,
Mhm.
it looks about a health of everyone, animals, planet, and humans. So anything
sorry.
that changes in like your environment, like your environment is polluted, is going to affect humans as well as animals.
Yeah, you're right.
And if animals are getting like some diseases that can transmit to humans,
Mhm.
then everyone is affected. And there are diseases that can transmit from humans to animals. So One Health looks at overall health of the planet
Mhm.
rather than just focusing on one component of that.
I mean, the thing which came in 2019 virus, the
Yeah, the COVID one.
coronavirus, it was also generated. Some says it was generated from bat, or some says.
Yeah, originally like it somehow came from animal source, but they are still not able to trace like when and how that happened.
So
But it's very much similar to the virus that was found in bats.
So that is the only reason. That's why the scientists have performed that. Okay, it has been originated by bats, or they have found the actual traces.
It's very controversial, so I probably don't want to go there.
Okay.
So there are two different theories, and like no one has a concrete evidence to show one way or another. So we'll know in future probably.
Do you know about any other virus which can harm the human life in future?
Yeah, like right now there is this avian influenza virus. So I don't know if you are aware of that. It's H5N1, one particular strain of avian influenza. And recently, like this virus only was supposed to infect birds.
Okay.
Poultry like ducks, turkey, and some other and wild bird species.
Okay.
But in US, is being detected in cows. Like the dairy cows are getting sick, and like they have also detected in milk.
Okay.
And it has zoonotic potential. That means like uh, in past, like some human being have been infected with this virus,
with the same virus,
but not at large scale as COVID virus. So that could be another important virus to look for and watch how it evolves and how. So far, it's not that risky because even someone gets infected, they cannot transmit it to another human being. So it's not human to human transmission yet.
Okay. So how does this particular virus get transmitted? As you said,
like it gets from the animals like birds or cows to humans.
Okay.
And that's why like that human cannot transmit it to another, like either their family or friends. But if the virus adapts further, like it changes some of its genes, then it can transmit from human to human, which happened in COVID, and then it can be a big issue.
And the medicine is already there?
It's a viral disease, so viral disease don't have any medicines, like it's mostly precautions. There are some antiviral treatments, but they don't have as promising effect as antibiotics or other things for bacterial diseases.
What do you think? What are the precautions we can take for that?
Yeah, same like if it happens, then you use like your personal protective equipments like masks and gloves, and wash your hands. Don't go out in public, things like that.
But that can only be true if that virus changes genes.
Yeah, there is no risk right now. Like it's a possibility that scientists have hypothesized, like this could be a next big thing for public health, and they have been preparing for it like for many years, like just researching and understanding how the virus evolves, how it can change. And recent one, like it was not infecting cows until last year probably, but like at the end of 2023 and from early this year, they are finding evidence that this
in humans also.
Humans, there have been evidence that humans have been infected with avian influenza before, but not on a large scale, like probably few hundred individuals so far. But since it started infecting cattle, now people are a bit concerned. Like there is not a big risk yet, but some are concerned that maybe it can jump that species barrier, and it can start like infecting humans on a large scale, and then human to human transmission can occur as well.
And that's very fascinating.
Yeah, it is very fascinating when you try to understand all these different dynamics, like what are the risks again, like who gets infected, how the virus evolve, all those sorts of things.
Yes. And I know we can't put everything in a small podcast, but what do you think? How the technology is helping the epidemiologists in doing more research than in earlier ages?
It's huge now. Like especially for how it spreads in the population. Like we build models because you cannot infect individuals and see how they transmit the infection to other people. That's unethical, right? That's not practical. So we do computer models, like we create individuals in the computer with the same properties, like how many people they meet every day, where they go. We add the properties of the virus, like how many days the virus is viable, how long it takes to get infected, how long someone remains infected, and we build mathematical equations. And from there, then we can predict, like if something happens in this population, this many individual can get infected, this many individual may need like this sort of care or like hospital beds and all that. So the technology is helping to prepare for all these by doing these computer simulation experiments that you cannot do in real population.
So no need of the lab rats anymore. I mean,
no, you still need lab rats like for other sort of thing, but these kinds of predictions or projections, even that type of experiment may not give you the right answer.
Okay. So if you want to tell us if any student wants to go in this particular field, and he have just done the, like, let's say if he or she is just graduated from the high school, what are the things they can go through to get into epidemiology?
So there are many different ways. Like first, to do the research, you need to have at least undergraduate degree. So if you have a strong, because it's mostly mathematics, like even if we call it epidemiology, it's mostly mathematics, statistics, and biology, like how individuals behave, how they react with others, and things like that. So if you have a strong mathematics, statistics, and biology background, so either you can get directly into a graduate program that teaches you public health, epidemiology, that kind of thing, or you can do a professional degree like MD or DVM, where you get trained as a human doctor or a veterinary doctor, and then after that you can transition into this type of research.
It's a long path for any student.
It is, yeah, it is very, like, at least after undergrad, another 6, 7, 8 years of training, and then you become like a researcher, and then if you want to go to become a faculty or like to become a scientist with the government, then you have to apply to those kinds of jobs.
And how do the salary expectations looks like when you go to the scientist level? If you,
It ranges like many factors plays in, but these are not like very high paying jobs as you would get in any private companies after having that kind of degree.
oh, okay.
So basically these are service like where you are not looking for money but more to
Okay.
like add to the knowledge.
Oh, okay.
So yeah, like ranging from anywhere around 80-90,000 to higher end of 150,000 depending on your qualification, your year of experience, all those kind of things. So not very like not minimal but not a lot of money, and most people are in this like at least in the science field for the sake of their curiosity and to find new knowledge rather than for money.
So if you are curious about veterinary, aquatic life, or these diseases, then you must pursue the epidemiology.
Not only this, there are so many different fields, like there are aquatic biology, there are marine science, many other things, and they all like they are cross cutting. Like you can, no one field is absolute in its own, right? Like it needs something from other field.
And what do you think the how is the future looks like in this field? If you
No, the
have,
future is good because there are so many changes happening with the climate change and like with diseases. So and like we need to feed a growing population. So the demand for food is always going to be there, and to have that in a sustainable way, you need to have properly trained scientists and students who can tackle the challenges. So there is always going to be a scope for work.
and if you want to add anything from your side, as if you have any questions which which I have not asked you, what do you want to add? If you have anything in your mind, you can say.
I don't think. I think we covered most of it. Uh, yeah, no. What I would say is like we talked mostly about North America here, like in this context. But there's huge population in Asia or Africa, like only in India, where more than 1 billion people, and they need good quality food. And these things are not done at the same level of standard as it's done in Canada, North America, like in USA. So there is huge scope to advance this field
In Asia.
in Asia, in Africa, where they need a lot of help, a lot of training to properly farm fish, to properly produce them.
Really good. Well, thank you for your insight, sir.
Yeah, no, it was my
And
pleasure, and thank
and
you.
I
Thank
really
you for this
appreciate your
opportunity.
time.
Yeah.
Thank you.